So I want to show you over here. This is pretty cool what they're doing, and I'll give you I'll try to give you the brief version because it's pretty cool. But so you see this box over here? This athlete is standing in this box. Okay. Now what's happening right there is there's all these cameras inside this box. Now you were talking about high tech and low tech. Like this is something that you're probably not going to get in most places in the world. But so he's putting his foot in the box right there. There's a bunch of cameras that are taking a ton of pictures of his foot. Now what's going to happen is right there on the screen you can see that 3D image right there. Yeah. That's his foot.
No way.
Okay? Right. Now,
so cool.
It's super cool. And so now what's going to happen after that is the company here that is working with us can actually make shoes specifically built for
their feet.
For their feet.
Wow.
So if we happen to see something, sometimes our athletes have different size feet, right? Maybe they're extra wide, maybe they're extra short, maybe they're extra long, who knows? So your average shoe isn't going to fit really well, right?
Yeah.
So these shoes, it's like a couple $100. It's really not a big deal at all. I was going to see...
How long does it take to scan the foot?
Not long.
From one of your athletes?
I think like a minute or so. I mean, while he was in there, yeah, it was really short. Now they do have to put little dots on your foot so they can tell where. Yeah, there's a little
hop in there.
There's a little prep that goes into it. Yeah. I want to see if they have the foot models.
Oh, yes. I wanted to tell you. Did you do this? No.
Yeah, this is a new thing we added this year.
It looks like it's like cutting edge tech. So.
It is. Yes, it is. In fact, I think they were telling me this technology they use. The U.S. military uses it to make like the helmets for the soldiers and stuff. Like for fighter pilots.
It takes 30 seconds to scan.
There you go. 30 seconds to scan.
You should.
Ooh, look at this.
Thank you.
Options.
We're going to put 4 dots on your toes. That's all we need.
Oh, I love the
4 dots on the toes.
That's it.
There we go. Oh, you're going to go through it. Excellent. All right.
So,
well, I'm very self-conscious right now. Drew, how are you?
Nice to meet you.
We're live on Facebook right now,
Oh,
so we're going
hey guys.
to show this technology.
Okay, so this is a scanner from Japan. It's called the INFOOT scanner. It's a 3D scanner. It's got anatomical measurement that we take from bone position. So right now I'm going to put landmark on Drew's first and fifth metatarsal bone heads.
Sounds good.
So I'll just stick one here, Drew, and the other on your first met head. So there are lots of 3D scanners out there, but this one is the only one that actually takes anatomical bone position. The outside shape of your foot is one thing, and the position of your bones inside is another. So to get inside bone shape, you either need a radiative penetrative scanner like CT or MRI, or you can use physical landmarks like on ours, which means it's a totally harmless scanning platform. So we'll get you standing even weight inside the scanner now, please, Drew.
Absolutely. Okay. Which foot would you like to do first?
We'll do your right foot first, so put your left foot up there and right foot in the center of the platform.
Excellent.
And we'll just pull your...
I just want you to stand normally.
Perfect. That's great.
And make sure that your hips are...
And if we could just get you standing up nice and straight, Drew. We need to close it off because it's a light-sensitive platform. So we're just going to close you up here for a sec, and the scan itself takes about 10 seconds.
Japanese foot scanning technique.
And
They put dots.
Just for a sec, please, Drew. Just hold
And
still.
if you look over on the screen, you're seeing what's actually taking place inside the scanner.
Oh my God.
So that's two-dimensional, what you're seeing there. And then we'll see a 3D model instantly. Now that's a combination of the accurate foot shape
Very accurate.
as well as known bone position. So if we go
Those dots are on my metatarsal, is what you said?
metatarsal, so that's the toe bones. So it's the head of the bone head,
Sort of like
the head
the
of the
knuckles,
bone.
so to speak.
Exactly right. Yeah. So we'll do your other foot. So we get a pair right in the middle. That's great. Hang on, we'll go up a little higher with your pants. Sorry, Drew. So this scanner, it's used in medicine, it's used in research, it's used in retail, sport, fashion, and we've got head scanners that are used by the F-35 project. Every pilot gets their head scanned for a custom-fit helmet. All their flight controls are inside their visor these days. So they control the aircraft, their navigation, even weapons from inside the visor. It needs to be a perfect fit, and they use these Japanese scanners from I-Ware Laboratory to achieve that. So this is your shape. Could we see a mesh, please, Jesse? That's the actual shape. That's ready for 3D printing or for CNC milling of any type of design platform. It's a CAD file ready to go.
That's my foot right there.
That's it.
Thank you so much, Drew.
So while
Thank
we
you.
can't certify you as an F-35 pilot, we can in fact certify that you do have 5 toes on each side. Congratulations, sir.
Thank you so
That's
much.
so cool.
We're supporting a company that Rob and Jesse and Deborah here from USA called Foot Options. We're taking the shapes of special athletes with a focus on the
every
Down
athlete gets a
syndrome
medal.
foot to try and achieve a shoe that is a much better fit for Down syndrome athletes in future. You've got them. You're going to
show them, yeah. Yeah. So this is what I wanted to point out. So what you're looking at here is basically like the average model of, let's say, an adult male's foot, size 9.5. That's basically like your average male foot. This is somebody with Down syndrome, an adult, their average size foot. I mean, you can tell the difference, right? This is like a boy's 1.5 foot.
Yeah.
Now, what you can see is if you kind of look at the width of these, the width of the foot is basically about the same, right? But the length is different. Now imagine if you bought like a an off the rack shoe and your foot was shaped like this, you'd have a lot of extra space out here because you would need it wide enough so you could fit in the shoe, right?
Exactly.
So that's what this is all about, is trying to accommodate the differences that some of our athletes have.